I will suggest then to continue. So we are happy here today to have Jennifer George. She's CEO in Strategic Commercialisation Australia. And she will share her experience with us from the health area and how in this area how there is a need for linked location information with the health data, in particular in this time, the COVID pandemic time, where this is even more important. So please, Jennifer.
Thank you. Thank you for the introduction. Can you hear me okay? No problem?
Yes.
Great, excellent. Okay, thank you, Chris, my friend Chris, for your overview. It was wonderful to hear all the different exciting things that you've been working on. And I wanted to also just note that I am also the chair of IT 268 for this Australian Standards group. So although I'm here as CEO of Commercialisation Australia, I'm also one of you guys. So I'm very, very pleased to hear all the exciting things that we're going to do together. So one of my aspiration is here to inspire you. Innovation is something that we all look at in the now, but I want you to see it over time. This is innovation is we're all, as Chris mentioned, we're all going to start looking at 4D, which is the element of time. I believe that the intersection of geospatial and medicine and medical is very much tied into time. So I hope this is more of a speech presentation than what Chris's was, but my aspiration here is to inspire you very much. So I hope we achieved that. So geospatial and health, it's about time. So here I am I'm speaking to you, as I said, as the CEO of Strategic Commercialisation Australia. So no, it is about time, but I'm not wise enough to be able to sit here in front of you and say, I'm going to deliver the seminal project about speech about black holes and the beginnings of the universe, a la Stephen Hawking. Nor, you will be glad to hear, will it be a temper tantrum where I say it's about time, that where an impatient geospatial modeler is kind of saying nobody gets them, that they're just waiting for people to get their ideas. No, that's not the time I'm talking about, but certainly this is a presentation about time. For the last 15 years, I have been commercializing deep tech, and medtech is part of deep tech. Deep tech is really about science and engineering and how they work together. So I work deep in the weeds of all the innovation, often at the cutting or even bleeding edge. So some of the things I might be telling you about today, you might not have even seen before. So I've commercialized quite a few different medical technologies, and it's all part of my work. So health has many parts, and I can't talk about all of them, but I'd like to speak today about some of the different parts that we might look at from the geospatial perspective, not just health generally, but diagnosis, treatment, contamination, recovery, near-term prevention, long-term prevention, and chronic and long-term care. So you can see there's lots of different parts. Every time as an entrepreneur, I dig into different areas. I see both limitations and difficulties, but I also see opportunities. And each one of these areas in health provides an opportunity for us to do more with the health community, all with data and diagnostics, and combining the geospatial data with these various areas. And I'm sure if each of you are looking at that list, you'd probably think, oh, well, actually, I know something that fits into that area, something that fits in long-term care, or a device that helps with recovery. So you already know some parts, but there's a lot of parts in all those different areas. So let's take a bigger deep dive into disease diagnosis, progression, and contagion, because, you know, as Chris mentioned, that's the world I'm living in on a day-to-day in my lockdown kind of society that I have here. We've learned a lot about different diseases. So when we look at time, so I'm saying, really talking about time here. So, you know, if you think about it, when we look at accidents and things like that, we say, oh, time cures all wounds, you know, it makes it all better. But when we're talking about pathogens, time actually is the ally of making that pathogen more voracious, more successful in the community. Because over time, simply put, diseases just get worse. It factors in as early diagnosis increases the effect of medication and reduces the life impact, but conversely, late or inaccurate diagnosis can be life-threatening and potentially life-ending. So if we can do something to help that transition from, you know, from late discovery to early discovery through data, we can do an amazing amount of things. So what kind of, we know about COVID. I mean, we're living COVID, but also there's a lot of other diseases, sepsis, pneumonia, HIV. They're all diseases that are related to bacteria. More recently in India, we found that there was major outbreaks of black fungus that previously wasn't life-threatening, but now because of the reduced immune systems, it is incredibly life-threatening for people who are already living with COVID disease. So we're kind of multiplying the effect because of the different kinds of compromised systems and diseases. Equally, time also worsens conditions like cancer, diabetes, all the other ones that we hear commonly are all impacted by time. So if we, with the geospatial world, could help with an early diagnosis, we could really make a substantial impact for the world here. So, but we know that COVID has improved our awareness. You know, everybody's an expert now. I mean, if you said PCR a few years ago, no one would know what it is. But I guarantee you that 50% of the population know that a PCR is just a machine for measuring the viral load of a COVID vaccine, of a COVID virus. So because of our use, we're actually going to become more aware. And so this is a change that's going to be happening, and that awareness should be matched with data collection. And so we must become smarter and more aware of how things work together. So we understand now that contamination works across environments. And indeed, we actually see that over time and in certain situations, it's going to be worse. And those things can be all mapped through geospatial. Digital technologies can help with this. And you know, in the progression of various pathogens, if we can do something to change all of this with digital by bringing and combining geospatial and digital technologies and personal technologies, put them all together, we actually have an opportunity to change the health of the world, which is a really exciting thing that we could potentially do. So here I'm going to give you a bit of an insight into my world of innovation and things that you might not know are occurring. So here's a few of the innovations that I've looked at in the last month or so. So there's a new a new test for sepsis, and it has developed that we can test, because we use AI, this test can now test for sepsis in 1 hour instead of 3 days. Again, remember, time is the element that needs to be addressed here. There's a new device that allows you can do a digital measurement and use image processing to be able to see if you have sepsis from your home rather than going off to the hospital. Remembering that sepsis kills millions of people every year. It's one of the most life-altering diseases in the world today. There's a new helmet that's been developed to identify at an earlier point, maybe in a plane or an ambulance, if you have a clot stroke or a bleed stroke, and so you can get that treatment right away. You only have 4 hours after you have a stroke to be able between the first stroke and total brain injury. So that means that you've got 4 hours, and if that 4 hours is spent traveling, whether it be on a autonomous vehicle or not, it doesn't really matter. It's the 4 hours you've got to get a diagnosis. So there's also a mobile phone. You can cough into your phone and figure out whether you have any kind of pneumonia or croup or any kind of, even COVID, and it's 85% accurate. A doctor is only 80% accurate. So the digital device is actually more accurate. So these are the kind of things that in the future that you might be looking at is, how do we standardize this? How do we bring in all of the new understandings that help to put all this together? There's also mobile ECG machines and epilepsy helmets that you can put on and play cards at home and have friends around while you're getting your ECG your epilepsy managed in real time. Diabetes and heart and pain, there's all kinds of ways of measuring and monitoring pain. In fact, you can use virtual reality to monitor pain in surgery. 60% of pain can be reduced simply by using the right kind of virtual reality. So these are some of the things that do we need a standard for that? Do we need to understand and make sure that people are using these things in the right way? Connecting all these technologies together, we've got Fitbits on our bodies, we've got telehealth, as was mentioned here. We, Chris talked about, we have a huge growth industry in telehealth, and what we'll be able to do is bring all these things together to be able to create new value. Okay? Add to this, you've got big data, AI, cloud computing, you've got the new ways of understanding, packaging, putting it all together. All of it goes together. It is not separate. It is not separate other parts of other things. We can't do a standard on cloud computing without thinking, well, what is it actually storing and how is it delivering value? So looking forward, we have new silicon chips. So the silicon chips that you have in your phone are the probably a midway iteration of where they are now. Silicon chips are going to be able to do 10 times more and give you at the same time 10 times cheaper and way more customization. So you can expect that every piece of edge computing technology that's available will have some kind of new smart chip in it very soon. And once an innovator gets hold of those things, you're going to see a lot of tech that comes out of that in the personal health space. So all of these things, you put these all together, they're not separate, they're all data. Everything works together. So we put them all into an environment with this data, with their data and environmental and geospatial data, we're going to have a huge impact. Think about the ability to customize and be able to say the environmental impact of these diseases on particular individuals. We can do testing in a lab, and we could test 10,000 lab samples and do predictive analytics on those samples in order to get to a result that would take us days or weeks. We can now do it in hours. So all of that must be considered when we're looking at standards. But in our rush to reduce time, let's not forget accuracy. I have to say, I just commercialized some COVID treatments in Europe, and I was like amazed, US and Europe, I was amazed at these number of different technologies that were around that didn't actually work. And so it was kind of reassuring when I saw in the press that the FDA had actually apologized for approving so many new PCR machines that didn't work. They were all giving false positives. And we even false negatives, it was really that they didn't deliver any real value whatsoever. So they apologized for that. And similarly, the CDC revised down the point of care devices, those very quick devices that they said, well, okay, you know, you can do a spit test or, you know, a lateral flow test or whatever it was. They reduced their rating for those down from 80% effectiveness to 42% effectiveness. That means that less than 50% of the time they were getting it right. In a 50-50 situation of yes or no, we were getting it right. We were getting it more wrong than right with these new devices. So we have to understand that as we rush to save time and we want to get predictive and we want to make sure that we deliver a better result, that we actually need to get it right. Accuracy and fast, accurate and fast. That's our goal, not just fast. It's really, really important. So each data device, of course, creates its own data, and that data is collected within a standard. And the standard format helps all the systems to be built together with interoperability in mind. Everything that is built today needs to be interoperable. We've got to look at the systems. Is it in Linux? Has it got the right telephone system? Is it all, is it proprietary? If it's proprietary and we can't add to it later on, and if it can't read any other information or be interlinked with other information, what good is it if we start to build the picture of somebody's personal health over time? It just won't work. So we need to collect all the data that's involved, right? And we need to be much more aware that that data is very important, and we've got to give it the big D, the big capital D of data, make sure that we're ensuring that we're solving a problem, that we're giving high quality data, that we've protected it, and that we've made it so that we're kind of working and setting standards that really make it valuable to everybody, right? And we can only do that when we look to the future instead of now. So whatever we have now is not where we need to be. Where we need to be is in the future, looking back. So if in 10 years' time, you look back and you say, well, this is, you know, we understood back then that the standards were required. We built our cities and we built our systems. Systems, buildings, architecture, infrastructure all last for 50 years. So now if we want to make changes by 2030 or 2050, we should be well and truly in progress right now. So we can't just assume that we will have a different kind of result if we haven't done anything different as we've gone along. We need to look forward and then come back and view our future and our past. So I know geospatial data and sensor design can't do everything. I get that. I understand that. We don't want to be all things to all men, or all people, I should say. But the reality is, if we work with our medical and health experts, you know, and try and work at ways where we can get more complete information, then we have the ability to predict the future. We have biological digital twins being developed. We have the ability to use bioinformatics to be able to see whether people are more responsive to disease or less responsive to disease. There's 30% of our population that cannot get a treatment whatsoever because they are not the group of people that medications are built for. We need to get more personal. We need to give them more customized understanding. So, but when it comes to disease, you know, really delivering impact by reducing the time is really in the wheelhouse of data analytics. And we really need to embrace that, not just with fervor, but with a feeling of urgency and responsibility. We've got to do it well, and we've got to make sure that all of the elements come together with responsibility. So in the past, our standards have really just been the bottom, the do no harm part of standards, right? So we build a bridge so it doesn't fall down, or we, say you've got to at least have made this area. We haven't necessarily talked about, well, the bridge needs to connect this community to another community, or and give them a quality of life. We only look at one element. We look at single elements. However, when we look at data analytics, we can put health and the environment together, and we can create customized treatments for so many people, customized new treatments for diseases, new understandings in health. And so we can be doing more for each individual, not just doing no harm. We can actually aspire, and we should be aspiring to doing better, and helping to create more of a lifestyle success and health for everybody, not just those 70% that are in that normal and healthy range. So let's come back to our friend here, Stephen Hawking. While he may have given us more insights about time than anyone else in history, he also lived longer than anyone else in history with motor neuron disease. And but in order to do that, he utilized a lot of digital innovations, speech, movement, and things that were not even considered at that time. In 2009, we actually just come up with a way of actually using your real voice in the speaking situation for ALS, right? And remember, everyone remembers the American voice that the Englishman, Stephen Hawking, was given. Now you can use your own voice as of 2019. Also, there's telehealth services specifically related to ALS that so that they don't have to travel, that they can get a full health coverage. So all these kind of services are starting to become available. But you know what I said is try and keep your eyes open for innovation, try to see things that are on the periphery. Well, just yesterday, I saw that our own Melbourne University has developed an item called a stentrode. And what it is a small little item that is inserted into the brain of a person who has neuromotor disease. And with that, they are able to think action, so that they can think to move their emails, they can scroll, they can change the pages, they can write text, and it's done through the brain-computer interface. So seeing things, being aware as we are of tech, we are all going to be able to start to envisage and change the future in a very meaningful way. So keep your mind open and things moving towards the future. But unfortunately, there's no cure at the moment for ALS, so for motor neuron disease. But eventually, when we do find a cure, I'm sure the people that work with Stephen Hawking and people who saw him live his life for his 40 years with muscle degeneration, they will all stop and they'll say, well, it's about time. So there we are. Thank you very much. That's my presentation.
Thank you very much, Jennifer. It's really about time to giving to us this, let's say, enlightening and mind-opening presentation of yours, showing, as I understood as well, how location information on top of emerging technologies like artificial intelligence, digital twins can enhance and improve services in such a domain like a health sector. And I'm just checking if there are any comments at the moment. But as said, so you're also the part of the panel later on, so we will have a further discussion later on if there are no further questions at the moment. So once again, thank you, Jennifer, for that.